Good morning. I'd like to welcome you all today to our webinar on engineering requirements for hoists with the engineering and sciences team here at the safety branch. Today, I know our session will have some excellent information on this topic, so it's great that you're able to join us through this webinar. My name is Brad Wells. I am an awareness and outreach officer with the safety branch. Before I begin, I would just like to acknowledge that where I'm presently located is part of McNaughey. We would like to acknowledge them as our past, present, and future caretakers of this land, and that our relationship is based on the spirit and intent of our sacred peace and friendship treaties. Today, we have subject matter experts with the Occupational Health and Safety Division, and of course, as I mentioned, Engineering and Science team. Leslie Ann Bateman, Colleen Rogerson, and Daryl Thompson are with us, and they are all professional engineers within the safety branch. Our first speaker today will be Leslie Ann Bateman, and I will let her lead us off now. Leslie Ann.
Thank you, Brad. My name is Leslie Ann Bateman, and I will be presenting the first part of our webinar. The use of hoists, in particular around wharfs and fishing vessels, is increasingly coming up as an area of compliance concern. With this in mind, the purpose of this webinar is to raise awareness in the engineering community about the nature of engineering work related for hoists under the Occupational Health and Safety Act, and to highlight regulatory requirements. Hoists may be commercially manufactured and come with manufacturer's specifications and other supports, but this is not always the case. Non-commercially manufactured hoists are a safety issue in Nova Scotia. They often have little to no documentation relating to their design or safe use. When there are no manufacturer specifications, an employer must have an engineer prepare instructions for using this equipment. This is a requirement under our workplace health and safety regulations. General duties and responsibilities for engineering work are set in the Occupational Health and Safety Act and regulations. Specific engineering requirements for hoists are provided under the Occupational Safety General Regulations, Part 7, Hoists and Mobile Equipment. We will discuss the regulatory requirements that engineers need to know when they take on work associated with hoists. There have been workplace incidents involving hoists that were not built according to engineering design. To raise awareness of this issue, a safety bulletin was issued. This was done in September of 2023. This safety bulletin can be accessed from the Occupational Health and Safety Division's website. A link is provided at the bottom of this slide. In general, hoists, both commercially manufactured and not commercially manufactured, can be found working in a number of different industries, including house lifting and moving, fishing, farming, and the automotive sector. The risks involved in using hoists vary from industry to industry and depend on the nature of the job. The probability of an incident reflecting frequency of exposure to the hazard, and the consequence of an incident reflecting the potential for harm, or the combination of both of these factors. For example, house lifting and moving is a high consequence risk due to load size. In another example, fishing is a high probability risk due to the large number of hoists and the added complications of installations on vessels. At this point in the webinar, we are going to start to focus more on the hoists used in the fishing industry. So how many hoists are out there? Here is our estimate. In terms of a land-based hoist estimate, there are 173 fishing wharfs, most of which have at least one hoist and may have multiple. For vessel-based hoists, There are approximately 7,149 registered fishing vessels in Nova Scotia. Often a vessel will have at least one hoist. In addition, we note that hoist installation is more complicated on boats due to vessel stability requirements. So what are we seeing in the field? OHS inspections have revealed that many hoists are not commercially manufactured, and the engineering work required for hoist equipment without manufacturer specifications has not been conducted for many of these hoists. We have been engaging with the fishing industry on this issue, and we are finding that fishers are concerned that there are not enough service providers, engineers who are competent in this work to aid in their compliance efforts. So what is the role of the professional engineer in work relating to hoist compliance? The role of the professional engineer is identified in the OHS Act and regulations under the OHS Act. In addition, the role of the professional engineer is also identified in standards incorporated by reference in regulations under the OHS Act. These standards, incorporated by reference, have the same force as regulations. We'll now take a close look at the role a professional engineer can play. Under Section 21 of the OHS Act, an engineer must take every reasonable precaution to ensure that a person relying on their work will be compliant with the OHS regulations. And an engineer contravenes the OHS Act if a person at a workplace is endangered by negligent or incompetent work. The term engineer is also defined in each of our regulations where engineering requirements for work are noted. This definition is that engineer means a person who is registered as a member or licensed to practice under the Nova Scotia Engineering Profession Act and is competent to do the work being performed. As noted above, an engineer must practice within the realm of their competency. A competent person is also defined under our regulations. A competent person means a person who is qualified because of their knowledge, training, and experience to do the assigned work in a manner that ensures the health and safety of every person in the workplace. A person who's knowledgeable about the provisions of the Act and regulations that apply to the assigned work, and knowledgeable about potential or actual danger to health or safety associated with the assigned work. At this point in the webinar, we are going to zero in on design requirements for hoists. Let's start out with how we define hoists. A hoist means a device or equipment and its structure used for lifting or lowering material, including cranes, an automotive lift, a winch, a chain fall, or other similar device, but does not include a lift truck, a power-operated elevating work platform, a device to which the Elevators and Lifts Act applies, or a hoist that operates in a shaft in an underground mine. So to review, in our regulations, hoist is used as a general term for machinery that lifts and lowers material, with certain pieces of equipment excluded that are dealt with as separate issues in the regulations. Referring to this graphic, winch versus hoist, under our regulations, therefore, a winch is a hoist by definition. The regulations have incorporated standards by reference that become requirements for the types of hoists that may be found at wharfs and on fishing vessels. CSA B 167-16 reaffirmed in 2021 overhead cranes, gantry cranes, monorails, hoists, and jib cranes is one standard. Another standard is CSA C 22.2 number 33. Electrical safety requirements for cranes and hoists. Our regulations incorporate these standards with the following language. Hoists must be designed, installed, erected, examined, inspected, tested, operated, and maintained by a competent person in accordance with the latest version of the applicable standard. I'm going to sidebar at this point to provide a bit of extra information about how we use standards in our regulations. The regulation will specify whether the entire standard is incorporated or just certain aspects of the standard. For example, whether design requirements or test requirements are adopted. In the case of hoists, certain aspects of standards are specifically identified. Latest version means in relation to a standard or other publication, the latest edition of the standard or publication as supplemented, amended, added to, replaced, or superseded. As you may be aware, a number of our CSA standards are being worked on with new standards coming into play as opposed to being updated by amendment. Our definition of latest version is broad enough to account for this. Finally, it is important to note that compliance with standards incorporated by reference is addressed in the general provisions of the regulations. Physical specifications, use, employer and employee responsibilities are dealt with here. Under the general regulations, this is section 6, but you will see similar provisions in other regulations. We often hear the word certified connected to engineering work. We do have a definition under the workplace health and safety regulations that relates to this word and working with standards. An engineer can certify that a standard incorporated by reference has been met. Certify means meeting the requirements of a standard as attested to by a certification organization accredited by the Standards Council of Canada or an engineer. Note also that the word certify can be and is used according to its plain meaning in the regulations as well. To certify means to attest as to being true or as represented or as meeting a standard. For example, under section 1.11 of our workplace health and safety regulations regarding engineer certification, an employer must obtain a written certification from an engineer that certifies that the employer's intended use of equipment provides an adequate level of safety for all persons at or near the workplace. Now back to the standards. The first one we are going to look at is CSA E167. The 2016 version, reaffirmed in 2021, is the latest version of this standard. In our regulations, the name of that standard is noted as Safety Standard for Maintenance and Inspection of Overhead Cranes, Gantry Cranes, Monorails, Hoists, and Trolleys. That standard is now called Overhead Cranes, Gantry Cranes, Monorails, Hoists, and Jib Cranes. Note that the name has changed, and this standard does specify design requirements. Here is more information on the scope of the standard. The standard provides the minimum requirements for the design, inspection, testing, maintenance, modification, and safe operation of cranes, including overhead traveling cranes, jib cranes, and gantry and wall cranes, monorails, hoists, and other material lifting equipment having similar characteristics to the items listed above. Notice here that cranes and hoists are defined separately in this standard. The terms crane and hoist are used generically to refer to all lifting devices within the scope of the standard. If a provision is meant to address a specific kind of crane or hoist, the appropriate term will be used in the standard. A crane is a machine with an integrated hoisting mechanism used for lifting a load vertically and moving it horizontally. A monorail is a hoist and trolley on a single overhead track. Hoist is a machinery unit that is used for vertical lifting or lowering a freely suspended, unguided load. Note that the scope of the standard includes important information about the level of detail of design information contained in the standard and what equipment is excluded from the scope of the standard and dealt with elsewhere. Many of the specifications in the standard specify cranes and hoists, or cranes or hoists. For example, Clause 4.1.1 of the standard specifies that the entire Clause 4 applies to all types of cranes and hoists. As I noted above, design requirements under the latest version of the standard are required under the regulations. These incorporate further design requirements by reference. For example, we have ASME, CMAA, and ISO standards for overhead traveling cranes, ASME B 30.21 for manually lever operated hoists, ASME B 30.16 for hand powered electric and air powered hoist, and others as well. That means that these other standards also apply to the extent indicated in B167. With our overview of B167 complete, I am going to pass things over to Daryl Thompson, our electrical engineer, to discuss the electrical standards.
Thank you, Leslie Ann. So as mentioned by Leslie Ann, the two main standards that are stated in Clause 722(1)B of the Occupational Safety General Regulation that relates to the electrical safety are the CSA C22.2 number 33 electrical safety requirements for crane and hoist, and CSA B167 safety standard for maintenance and inspection of overhead crane, gantry crane, monorail, hoist, and jib crane. It should also be noted that the installation needs to be compliant with the Canadian Electrical Code. Next slide, please. It should be noted that CSA C22.2 number 2033 applies to all type of electrical cranes, including electric overhead traveling cranes and hoists for vertical lifting and lowering of freely suspended load for voltages 750 volts and less between conductors. And as said earlier, this also needs to comply with the Canadian Electrical Code. Next slide, please. And this slide just reiterates the same requirements that the crane has to be compliant with the electrical code. Next. A few of the requirements that the engineer will have to take into account when certifying the non-commercially manufactured hoist includes the following below. 1, grounding and bonding. It is imperative that grounding and bonding conductors maintain continuity or are not damaged for the safety of personnel as well as the protection of equipment through protection device responding adequately. You can review grounding and bonding in CSA C22.2 number 41, which entails grounding and bonding equipment. Second, environmental consideration. Exposure to the environmental conditions must be taken into account. Therefore, installed electrical equipment must be adequate for the environment to withstand such things as salt, sun rays, temperature fluctuation, and the nature of the work. Conductors to be used outdoors need to be enclosed in conduit, or they need to be rated for outdoor use. You can review environmental consideration in CSA C22.2, number 94.1 or 94.2, which entails enclosure for electrical equipment, environmental consideration. Installation protection. This is important, and it is how and where equipment is installed, and it should not, how it is installed should not create an additional hazard to personnel during normal operation or during maintenance. Next consideration, doors and cover plates. Doors and cover plates need to be adequately installed. Enclosure working space. The minimum working space around enclosure is 30 inches secure footing. This needs to be provided and maintained around the enclosure access. Panel doors should be able to swing open fully to 90 degrees. And you can find this information in CSA 22.2, number 33 as referenced below section 5. Next slide. We're continuing on with the requirement. Another requirement is disconnecting means. All ungrounded conductors of the circuit must be capable of being simultaneously disconnected quickly for safety in an emergency and for maintenance. The disconnect must be within sight of the main contact conductor or the equipment if there are no contact conductors. In addition, the disconnect must be accessible and be operable from the ground or the floor over which the crane or hoist operates. The next important point is exposed non-current carrying metal parts must be bonded to ground. So which design requirements apply? So we have included some pictures to show the variety of hoists we are seeing in the fishing community. Next slide. So which design requirements apply? When design engineers or engineers are certifying these hoists, they have to first characterize the hoist. Then they have to identify the type of hoist it is by referencing the scope and definition on looking into the applicable standards. And then they need to apply the relevant design requirement in their assessment of the hoist. Next, we will have Colleen, our OHS engineer, continue with the regulatory requirement.
So at this point, we just want to mention that the fishing industry is one of the few industries that has legislation that applies to it with regard to health and safety, both federally and provincially. So federally, it's the fishing vessel safety regulations that apply to fishing vessels, and they have a role to play when hoists are placed on fishing vessels. This is just an excerpt from a Transportation Safety Board investigation into a vessel that sank, a fishing vessel that sank that left the Digby Wharf in 2020. This is Chief William Solis. But what you'll find in a lot of these investigation reports of fishing vessels that have not returned home is that stability is often a concern and the role it played in the failure of those vessels to return. In this particular case, they say all fishing vessels must have adequate stability to undertake their intended operations. And TC, which is Transport Canada, may request that the authorized representative demonstrate the adequacy of a vessel's stability. Although many fish harvesters use the feel of their vessel and past experience to determine stability limits, this is not reliable. Stability should be measured through a formal stability assessment and connected to the safe operating limits and practices of the vessel. So just a couple of excerpts from the regulations for fishing vessel safety federally. This one applies to maintenance of equipment and machinery, and it covers the fishing vessel as well as its machinery and equipment, and says that it shall be maintained to ensure that it's a safe operating condition. So a hoist on a fishing vessel would fall under this particular regulation. And this regulation outlines who can do a stability assessment. And as you'll note, it is a professional engineer who's registered with a province in Canada or somebody who's registered with a state in the United States of America. They also permit classification societies to do this work or naval architects. And just to kind of emphasize that engineers have a role to play in stability assessments, Engineers Canada has put out a position statement on their concerns around stability assessments in the fishing industry. So we're going to go back and do a little bit more review of regulatory requirements for hoists from the provincial regulations. So we're going to look at some general requirements, and I say general requirements because they don't apply only to hoists. Some of them apply to hoists and lift trucks and cranes. But we also have specific requirements that are unique to hoists. And we're also going to look at the requirements that come from the standards that are incorporated by reference. So if we look at the workplace health and safety regulations, there's specifications for equipment, for components of equipment, or components of a system. And then our other regulation, the occupational safety general regulations, has specifications for hoists. But it also has that general requirement. So in this case, it says it has to be erected, installed, assembled, used, handled, stored, etc., according to the manufacturer specifications. And in the absence of manufacturer specifications, it has to be done according to specifications prepared by an engineer. So it deals with the use of equipment. And as mentioned, if there is no manufacturer specifications provided with the hoist, then the employer must have specifications prepared by an engineer. And they must be certified by that engineer. The workplace health and safety regulations in section 1.11 provide good guidance on what an engineer's certification for the use of equipment should look like. The engineer must first ensure that the use of the equipment as intended by the employer is in accordance with generally accepted engineering practices. Then the engineer certifies in writing that the employer's intended use of the equipment provides an adequate level of safety for all persons at or near the workplace. An engineer identifies as part of the written certification any measures to be taken to provide an adequate level of safety, and the engineer signs the written certification they prepare. So just digging a little deeper into measures to be taken to provide an adequate level of safety. For hoists, precautions to be identified or those measures to be taken to provide an adequate level of safety could include the load limit, the inspection type, the inspection frequency, installation requirements, safe working load, having it posted in a visible location, and the foundation requirements for mounting that hoist. So requirements in the standards that are incorporated by reference, again, were CSA B 167, overhead cranes, gantry cranes, monorails, hoists, and jib cranes. CSA C 22.2, number 33, electrical safety requirements for cranes and hoists, and ASME standards for rigging equipment, including slings, hooks, and below the hook lifting devices. So an example is, inspection requirements are covered in CSA B 167, overhead cranes, gantry cranes, monorails, hoists, and jib cranes. Under clause 6.1.3 of the standard and table 2, the frequency of frequent inspections and the frequency of periodic inspections of an unclassified special crane or a hoist is as recommended by the manufacturer or an engineer. Some specific requirements for hoist include inspection, testing, maintenance, rigging, special use, and out of service. We're going to just touch on those just a little bit in the upcoming slides. So looking at inspection, CSA B167 references a role for engineers in the determination of inspection schedules, supervision of periodic inspections, and the development of frequent and periodic inspection procedures. So anybody who is looking to create inspection procedures might find this document handy. This was prepared by WorkSafe BC in collaboration with the Engineering and Geoscientists Association in British Columbia. Their legislation is not identical to Nova Scotia's. There's certainly a lot of similarities, and it's certainly a useful document for anybody who's just starting to try and put together that kind of documentation for inspections of hoists. So if we look at testing, CSA B167 references a role for engineers in the commissioning process, which includes an initial inspection and testing, including load testing, prior to being put into use. A statement of the rated load must be obtained from an engineer if one is not available from the manufacturer. Likewise, a revised statement of a rated load is required for modified equipment. And the employer must obtain a certificate from an engineer annually for an overhead crane with a capacity over 5 tons. For testing, load tests cannot apply a load in excess of the safety factor identified by CSA B167, the manufacturer or an engineer, if no standard or manufacturer certification exists. For maintenance, CSA B167 references a role of engineers in the supervision of maintenance work and welding work. And for rigging, where none of the cited rigging standards apply, so none of those ASME standards apply, an employer shall ensure that the rigging hardware complies with an adequate design certified by an engineer, using certification requirements under the Workplace Health and Safety Regulations in section 1.11 as a guide, that those conditions can be met. For special use, CSA B167 requires an engineered overcapacity lift plan for overcapacity lifts. And lastly, for out of service, equipment taken out of service cannot be returned to service until it has been inspected, repaired as necessary, and recertified by the manufacturer or an engineer, if the manufacturer's certification is not possible. So at this point, we will accept questions, but before doing that, we're just going to go through some of our resource slides at the end of this presentation. Thank you. We'll now take questions.